Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So let's continue on lecture in estimation, right? Chapter number 2. So last class we already looked at how to find estimation of difference between means, right? For known variance when the population variance are known, right? For today we're going to continue looking at under same estimation, which is estimation of difference between means. This time when the population variance are unknown, right? So let's look at theorem number 5. So in theorem number 5, it says that when you have two population, right, and then these two population we don't know the population variance, and either both are sample are very small, which is less than 30, both sample less than 30, right? The procedure is not straightforward. It's not like the theorem number 4, which is we just using z value, right? We need to assume that the population variance for both population variance are equal, right? In this, when we don't really know the population variance, we need to assume that both population variance are equal. So then we can use Z distribution, right? So the Z distribution assume when assume the population variance equal. So you will get the value of Z is x bar 1 minus x bar 2 minus mu1 minus mu2 divided by sigma multiplied with 1 over n1 plus 1 over n2. So this is going to lead us to a standard normal distribution. So in this theorem, sigma, which is a population standard deviation, can be estimating by pulling the square deviation from the means of two sample. So since the sample size for both groups are very small, right, and then we need to assume that with these two distribution have equal variance, right? When we assume that these two distribution have equal variance, then we can get the Z distribution, right? So otherwise we can estimate the population standard deviation by using the pool standard deviation, right? So the pool standard deviation is can be estimated by S square pool, which is equal to n1 minus n2 multiplied with S1 squared, which is the variance sample variance squared, and n2 minus 1 multiplied with sample variance, and divide by number of sample size number 1 plus sample size number 2 for group number 2, right, minus 2. So this is what we call as a variance, pool variance, right? So if you want to find pool standard deviation, so you just need to take the square root of pool variance, right? So this is just a formula for finding pool standard deviation and pool variance, right? So let's recall some theorem in sampling distribution, chapter number 1, right? Like if x bar and s square are mean and variance of the random sample of size n from a normal population with mean equal to mu and standard deviation equal to sigma, and then we can say that when x bar and sample variance are independent, the random variable n minus 1 s squared divided by sigma squared has a chi-square distribution with n minus 1 degree of freedom. So this one we already look at theorem number 3, I guess, in chapter number 1. N minus 1 s squared divided by sigma squared is having a chi-squared with n minus 1 degree of freedom, right? This is a theorem that we need to recall. And let's recall theorem number 2 in chapter number 1. If y and z are independent random variable, right? Y and z are independent random variable, and y having a chi-square distribution with v degree of freedom, right? And z has a standard normal distribution, right? So the t distribution is z is now standard normal distribution divided by the square root of chi-squared divided by 8 degree of freedom. We will get the t distribution with v degree of freedom, right? So this one going to get t distribution with v degree of freedom. So by remembering these two theorem from chapter number 1, so it will lead us to theorem number 6, right? So in theorem number 6 says that when we have two population, right, x bar 1, x bar 2 is the mean, sample mean of two population. S1 and S2 are the sample variance of a sample standard deviation, right, for these two group. Independent random sample of size n1 and n2 from a normal population, with equal variance, right? Equal variance. Then the interval estimation, right? When this is when unknown population variance, and we need to assume that sigma 1 equal to sigma 2, right? Means they have an equal standard deviation, population standard deviation. And the second condition is we need the sample size of group 1 and group 2 are less than 30. So this is the condition for theorem number 6. So then when the conditions are met, then we can use this theorem number 6. So interval estimation for theorem number 6, x1, x bar 1 minus x bar 2 plus minus, right? We are using t distribution with alpha divided by 2, n1 plus n2, right? n1 plus n2 minus 2, and then we need to multiply with the pool standard deviation, multiply with 1 over n1 plus 1 over n2. So if you can relate this equation, it's just like it just look like Z distribution, theorem number 4, right? Where by in this case, in theorem number 4, we say that sigma 1 divided by n1 plus sigma 2 divided by n2, right? This is the condition. Sigma, right, like this, right? So when we assume sigma 1 and sigma 2 are equal, then we can take out the sigma outside, and then it become a pool standard deviation, right? The pool standard deviation formula is n1 minus 1 multiply with sample variance plus n2 minus 1 multiply with sample standard deviation, sample variance, divide by the degree of freedom. Yeah, the degree of freedom is n1 plus n2 minus 2, right? So this is what we call as pool variance, sample variance, right? So now look at example number 1 to understand how to use the formula, right? How the interval estimation work in using that formula. Let's look at example number 1. So a study has been made to compare the nicotine content of two brands of cigarette, right? 10 cigarette of brand A has an average of nicotine 3.1 milligram with a standard deviation 0.5 milligram. And the second brand, 8 cigarette brand B, has an average of content 2.7 milligram with a standard deviation of 0.8 milligram. So let's jot down the information the statement gives us. So we have brand A and we have brand B, right? So in brand A, we have N1 equal to 10. Brand B, N2 equal to 8. Right? And then the average or the mean of brand A, so let's say brand mean 1 equal to 3.1. Mean 2 equal to 2.7. And the standard deviation for the sample standard deviation for brand A is 0.5, and sample standard deviation for brand B is 0.7. So assuming that two sets of data are independent random sample, which is not related at all, from a normal population with equal variance, right? So we assume that this population variance for number 1 is equal to population variance for number 2, brand B. And of course, in this example, we do not know the population variance, right? So in this case, the population variance are unknown. Right? And then we assume that the population variance, right, are equal for both group. So, and then the third condition is N1, N2 is less than 30. So we're going to use theorem 6. Right, so this is the condition that we need to meet. Right, so construct 95% confidence interval for the difference of between mean nicotine content of two brands of cigarette. Right, so now since we're going to use a theorem number 6, so theorem number 6 says that x1 minus x2, right, plus minus T alpha divided by 2, and then this is N1 plus N2 minus 2, and then we have pool standard deviation multiplied with 1 over N1 plus 1 over N2, right? Right. So pool standard deviation, let's calculate for pool standard deviation. Pool standard deviation is N1 minus 1 multiplied with sigma S1, this is a standard deviation, plus N2 minus 1 multiplied with standard deviation for group number 2, and then this is a degree of freedom, N1 plus N2 minus 2. So this one should be equal to 10 minus 1, and then the square root of 0.5 plus this is 8 minus 1, the square root of 0.7, right, divide by the degree of freedom is 10 plus 8 minus 2. So this one going to lead us to 0.596, right? So once we already know the pool standard deviation, right, so we just need to plug in the value into the formula. So x bar 1 is 3.1 minus 2.7, right? So we just input the value into the formula. Plus minus T alpha divided by 2 is, since we are trying to find 95% confidence interval, right, the distribution should be like this, right? This is a difference. So inside is 95%, and this is 2.5, 0.025, 0.025. So this is T alpha divided by 2, T alpha divided by 2. So T 0.025 and the degree of freedom is 18 minus 2, which is equal to 16. This is equal to 2.120. This is from a statistical table, right? We just plug in the value 2.120 multiply with 0.596 multiply with the square root of 1 over 10 plus 1 over 8. So when you do a calculation for this one, you should get negative 0.20, right? This is mu1 minus mu2 and this is 1.00. So this is the probability that we want to find, equal to 95%. So we can say that we have 95% confidence that the difference of two population mean, right, mean of two nicotine are between negative 0.2 and 1. So that's how we solve the problem, right? So now let's look at example number 2. So in example number 2, same situation, we have station 1 and station 2. In station 1, we have N1 equal to 15, N2 equal to 12. X bar 1 is 3.884, X bar 2 1.49. S1 3.087, S2 0.80. So we need to find 95% confidence interval for the difference in the true average of these two stations. Assume that the observation came from a normal population with the same variance, right? Look at the condition. We have same variance. Maksudnya means population variance number 1 equal to population variance number 2. And then number 2, condition number 2, N1 and N2 are less than 30. And condition number 3, we don't know the population variance. The value of population variance, we don't know. Right. So by looking at the condition, we will use the theorem number 6 to solve the problem, right? So theorem number 6 says that when the population variance are the sample variance are the population variance are known, population variance are unknown, and 1 and N2 are less than 30, and we have the same population variance, so we need to find a pool standard deviation. Pool standard deviation, right? Before I forgot this one, we need to take a square root. Yep, this is a square root. So this one should be square root of N1 15 minus 1 equal to 14 multiply with the standard deviation number 1 3.07 plus 11 0.80 divided by the degree of freedom is 15 plus 12 minus 2. So it should be 15 plus 12 is 27 minus 2 25, right? So this one should be equal to, so this is the pool standard deviation. This is, yeah, this is a pool variance, right? So I think this one, this is not square root of 0.5, this is 0.5 squared, right? 0.5 squared, this is 0.7 squared, is it? Yeah. So this one, let's calculate whether it's correct or not. This one 0.5 square multiply, yeah, it should be 0.25. Yeah, correct. The answer is correct. Right. Where is it? Yeah, this one. So this one should be 3.07 squared, and this is 0.2 squared. So this is going to be 2.35786. Right. So since we're going to use as theorem number 6, we just input the value into the formula. So T alpha divided by 2 N1 plus N2 minus 2 as pool standard deviation multiply with 1 over N1 plus 1 over N2. Right. And this one should be 3.84 minus 1.49, right, plus minus the degree of freedom, 95% confidence interval, right? So we want to find this area 0.025 and this area also 0.025. T 0.025 and the degree of freedom is 25. It should be equal to 2.060, right? So this is 2.060 multiplied with 2.35786 multiply with 1 over 15 plus 1 over 12. So this way, if you calculate this one, you should get 4687 mu1 minus mu2, and then the upper control limit is upper confidence limit is 4.2312 equal to 95%. So you can say that we have a 95% confidence that the difference of two population mean is between 0.46 and 4.23, right? Okay, let's move to the next topic, which is estimation of variance, right? So the population variance quantifies the amount of the variabilities in the population, right? At many times, the actual value of population variance are unknown to an experimenter. So then we need to estimate the population variance. So let's recall some theorem in chapter number 1. We know that the population sample variance, the formula for sample variance is summation of yi minus mean of y, then squared divided by n minus 1 is unbiased estimator for the population variance. This is we already know from the previous topic. We also know from a previous theorem n minus 1 s squared divided by sigma squared have a chi-squared with the n minus 1 degree of freedom when the sample size are from normal population. This is that we need to recall. We need to recall these two theorems. So now look at theorem number 7. If standard deviation is a sample variance is the value of variance of the random sample of size n from a normal population, so then we can estimate the population variance by using the formula from the chi-squared distribution. N minus 1 s squared divided by chi-squared alpha divided by 2 n minus 1. And n minus 1 s squared for the upper confidence limit is 1 minus alpha divided by 2 n minus 1. Right? So why 1 minus alpha? So if you look at our statistical table, right? In our statistical table, let me draw the distribution curve first. The chi-square distribution is look like this, right? So this is from 0 to infinity. So in our statistical table, they give us the reading on the right hand side, right? So this is our alpha divided by 2. So this is our alpha basically. This is our alpha. This is from our statistical table, right? This is chi-squared alpha divided by 2 and the degree of freedom lah. So if we want to find both sides, right? This is alpha, just alpha. If you look at into the statistical table, right, we will get chi-squared alpha n minus 1. So this is for a single-sided, right? If you want to find for the both side, right, let's say this is alpha divided by 2, this is alpha divided by 2. Let's say you want to find both sides. So this is another side. This is alpha divided by 2. So this one should be chi-squared 1 minus alpha divided by 2 n minus 1. Because in a chi-square distribution, so we only have a single-sided. This is a skewed to the right distribution. Unlike standard normal distribution, we have both sides. We have skewed. We have a side on the right hand side. Area on the right is also equal to area on the left hand side, right? So that's why we need to minus by 1, because the probability, the summation of all probability is equal to 1. That's why we need to minus by 1, right? So because this value itself is the value of probability, right? So the theorem number 7 is depend on our statistical table, right? So let's look at theorem example number 1. So in example number 1, in 16 tests run, the gasoline consumption of an experimental engine had a standard deviation of 2.2 gallons. So this is a standard deviation, sample standard deviation from 16 tests. So we need to construct a 99% confidence interval for the population variance. We want to estimate the population variance, measure the true variability of the gasoline consumption of the engines, right? So let's jot down the information that we have. We have basically n equal to 16 and the sample standard deviation equal to 2.2, right? So by using the formula, we want to find the probability of we want to estimate the variance, population variance, right? Probability of n minus 1 s squared divided by chi squared alpha divided by 2 n minus 1, and this is n minus 1 s squared divided by chi squared 1 minus alpha divided by 2 n minus 1. So this is equal to 99%, right? So now we know the value of n equal to 16. The standard deviation, sample standard deviation equal to 2.2, right? So let's draw the distribution for a chi-square, right? So this is a chi-square distribution. So we want to find 99%. Let's distribute another these two areas equally, right? So let's say this is the area that we want to find. So this is 99% of the probability. So the variance should lies between 99%. So this is a chi-squared alpha divided by 2 n minus 1. This is a chi-squared alpha 1 minus alpha divided by 2 n minus 1. So if we divide the area equally, so this one should leave us 0.005 and this is 0.005. So we distribute the area equally. So at this stage, right, at this stage we know the chi-squared 0.05. So 1 minus 0.005, n minus 1 is 16 minus 1 equal to 15. And this is a chi-squared 0.005, 15, right? So this one should be equal to chi-squared 0.995, 15. So by looking at the statistical table, this one should be equal to 4.601 and this one should be equal to 32.801. So we already know the value, just plug in the value into the formula. So the probability of 15 multiply with the s squared, this is s 2.2 squared divided by 32.801. This is the population variance. 15 2.2 squared divided by 4.601. So this is going to get us 99%. So the estimation of population variance is between 2.21 and 15.78%. At 8, this one going to lead us to 99%. So you can also rewrite the equation to 2.21 15.78 to indicate the confidence interval. So we have 99% confidence that the population variance should be lies between 2.2 and 15.78, right? So this is how we solve the problem lah. So let's look at another example, right? Look at example number 2. So example number 2, a student works with a blood lab test, tested a 10 woman for cholesterol level and found the following values. So we have 168, 164, 272 until 242. We need to calculate the sample mean and sample variance and then construct 90% confidence interval for the population variance. So this one, we already know the formula. This is going to be very easy. So the first one, the samples and the sample mean should be equal to summation of x divided by n. So this one should be 2325 divided by 10. We have only 10, right? So this is going to lead us to 232.5. And sample variance is equal to summation of xi minus x bar squared divided by n minus 1. So this one should be 11988.5 divided by 9. So this is 1332.05. So to calculate the 90% confidence interval for true variance, right, the population variance, so we will use the formula n minus 1. This is n minus 1 sample variance divided by a chi-squared with alpha divided by 2, n minus 1. This is population variance, n minus 1 s squared divided by chi-squared 1 minus alpha divided by 2, n minus 1. So this is the probability that we want to find, 90%. We just plug in the value, but before we do that, we need to draw a distribution curve. So we let distribute the probability equally on the both side. So this is 90%. So this one to be 0.05 and this is going to be 0.05. So this is chi-squared 1 minus 0.05 and minus 1, n is equal to 10 minus 1, 9. The chi-squared 0.05, 9. So this one should be equal to 3.325 and this is going to be equal to 16.919. Right? Just plug in the value into the formula. 9 multiplied with the sample standard variance is 1332.05 divided by this is going to be 16.919, right? And then this is going to be 9 multiplied with 1332.05 divided by 3.325, right? So this is going to lead us to the lower confidence limit is 708.58, right? And the upper confidence limit is 3605.56. Right, so we have 90% confidence that the population variance will lies between 708.58 and 3605.56. Right. So let's move to the next example. This is a simple example as well, right? It's the same example, right? Example number 3. Basically, in this topic, I have 6 examples, but I'm not going to do all, right? I'm going to leave it to you. So you can get this note from Google Classroom, right? So please solve for example number 3, example number 4, and example number 5. Until example number 6, right? So I leave it this example for you to do as your homework, right? So please do, if you want to understand more on this topic, please do as your homework, right? Please complete example number 3, 4, 5, 6, right? So let's look at the summary of interval estimation, right? From the last lecture, we already looked at one population mean, right? So to estimate the single population mean, when the population variance are known, right? So we will use this formula, x bar plus minus z alpha divided by 2 sigma over square root of n. This is when the population variance are known. When the population variance are unknown, and provided that the sample size are more than 30, right, which is a sample size is large enough that we can apply the central limit theorem, so we can still use the same formula, which is x bar plus z alpha divided by 2 sigma over square root of n. When the population variance are unknown, right, when the population variance are unknown, this is the same condition, population variance are known, but the sample size is more than 30. And the sample for the last condition is when the sample size is less than 30, then we cannot apply the central limit theorem to the sample, right? So we need to use this formula with a t distribution, x bar plus minus alpha divided by 2, t alpha divided by 2 n minus 1 s divided by square root of n. So this is when we want to estimate the population variance, so population mean, mu, right? So summary number 2, when we have two population, right? So we want to estimate the difference of mean, difference of two population mean, right? So when the population variance are known, So we will use the Z distribution, x bar 1 minus x bar 2 plus minus divide by, Z alpha divided by 2 and sigma 1 square divided by n1, sigma 2 square divided by n2, and then taking a square root. So this is when the population with the sample size is more than 30 or less than 30, right? You can use this one either more than 30 or and less than 30, right? So when the population variance are known, right? When the population variance are unknown, right, and the sample size is more than 30, right, so we can use Z distribution, right, and then replace this one to sample variance, right? So this is another condition, right? When we have a small sample and we assume the population variance equal, so we can use this formula, x bar 1 minus x bar 2 plus minus t alpha divided by 2 with the degree of freedom n1 plus n2 minus 2, multiply with pooled standard deviation and multiply with square root of 1 divided by n1 plus 1 divided by n2. Right, the pooled standard deviation, you can get it from this formula. Where is it? So this is a pooled standard deviation, n1 minus 1 multiplied with sample variance population for sample variance number 1 plus n2 minus 1 multiplied with sample variance number 2 divided by the degree of freedom, right? So for summary number 3 that we already learned, when the population mean are known, right, when the population mean are known, so we will use n multiply with s squared divided by, so if you notice the formula just have one difference. The difference is whether you need to minus by 1, the sample size minus 1, or sample size not minus 1. So this is minus 1, this is not minus 1. So when the population mean are known, then we need to take the whole sample. When the population variance population mean are unknown, we need to use n minus 1 to find the population, to estimate the population variance, right? So I think that's all, right? If you have any question, you can leave it on the chat column, right? And then if you later on, if you still have a question, you can WhatsApp me personally or put it in the group, right? Or just put it into the comment box below, right? Okay, I think that's all. So once we already finished chapter number 2 basically. So since we already finished chapter number 2, you should bear in mind, you should know that we going to have test number 1. So test number 1 for this semester, we only focus on chapter number 2 because chapter number 2 is very long chapter, right? Okay, I think that's all. Thank you very much. Assalamualaikum.
Link, here come to town, come to save the Princess Zelda. Got it put away, now the children don't play, but they will when Link saves the day. Hallelujah! Now Link, fill up your hearts so you can shoot your sword with power. And when you're feeling all down, the valley will come around, so you'll be brave and not this is a coward. Now Link has saved the day, but got it in his granite. So now a valley is free, and now a hill shall be. Link, I think your name shall